So hello everyone, welcome you all to this new video. So as I've told you already, I have started with in this playlist I'm going to cover all the 5 modules of the second semester maths for EEE stream. I had already started the module vector calculus and 2 videos are uploaded in this playlist. So in this playlist we are going to continue with the 3rd video of this module, where we are going to continue with some of the problems only where we have left in the last video. So again, those who have not watched those previous videos, guys, please go and watch it. It is available in the channel in this playlist only. Okay, so those who are new to this video, please like this video, share this playlist to a huge number and subscribe to our channel for the latest notifications. Okay, so we are going to provide the latest contents which would be required for you all during the preparation of your exams. Okay, yeah, so we are going to continue with the problems only in this video. We are going to solve around 3 problems which are related to angle between the surfaces and one problem related to directional derivative. Okay, yeah, let us see this question now. The third question, we have already solved 2 questions in the previous video. Third question is, find the dd, that is the directional derivative, if phi, that is the scalar point function phi, they have given it as xy square plus yz cube at the point 1, 2, minus 1 along the direction normal to the surface if they have given one more surface, that is psi, equal to x log z minus y square at minus 1, 2, 1. Okay, so in the previous problems what they had given directly one vector. Okay, one vector they had given, but here they had not given the vector potential, they had given only the scalar potential. What we should be doing, we should be finding here in this case the formula for n cap is equal to del psi divided by magnitude of del psi. Okay, but in the last 2 previous problems what we had, the formula n cap is equal to d vector divided by magnitude of d vector, right? Because they had given directly the d vector, so we could do it directly. But here we should be first finding the gradient of this psi and then we should be solving for n cap. Okay, yeah, for del phi, how as it is we should be solving. So first let us solve for del phi. So we know the formula for the directional derivative, that is del phi divided by n cap, right? So for that we are solving first del phi. So what is del phi? So del phi formula, again I am not writing it. So here they have given the phi, so I'll write phi here, xy square plus yz cube. Okay, so this is phi, right? So for this, first we should be partially differentiating this whole equation with respect to x. That is, here we have x, here we don't have x. So differentiation of x is 1, y square I cap, then plus the whole equation with respect to y now. So we are here in both the terms we have y. So differentiation of y square is 2y. So 2yx plus differentiation of y is 1. So plus z cube into j cap plus z term, partially differentiating. Here we don't have z, here we have. So z cube, the differentiation is 3z square, 3yz square into k cap. Okay, now substitute the values of x, y, z in this equation, that is at point 1, 2, minus 1 they have given it. So y square is 2 square, that is 4, plus 2xy, that is 2 into 1 into 2, that is 4 again, plus z cube, that is minus 1 the whole cube, that is minus 1, plus 3yz square, so 3 into 2 into 1 square, that is 6 k cap. So our answer is del phi is equal to 4i cap, 4 minus 1 is 3, plus 3j cap plus 6k cap. Okay, so this is del phi. Now find n vector. The formula is I have written it. So for that what we should be doing, we should be finding del psi now. Okay, so I'm writing psi here, that is x log z minus y square. Okay, for this now again partial differentiation, the same thing, that is first partially differentiate with respect to x here. So if you see here we have x here, so partial differentiation of x is 1, so we are left with log z into I cap plus y. So here we don't have a y term, here we have y term, so the answer is minus 2y the differentiation of y square is 2y into j cap plus z term. Here we have one z term, that is log z. Okay, so differentiation of log z is 1 by z, so x into 1 by z, that is x by z into k cap. Okay, so differentiation of log z is 1 by z. Differentiation of any term with which we have log, so that would be equal to 1 by that term. Okay, hope you might be knowing it. So now substitute the values of the question here. In the question they have given -1, 2, 1. So log of 1 into I cap plus 2 into -2 into 2, that is -4 j cap plus x by z, that is -1 divided by 1 into k cap. Okay, so our final answer of del xi log 1 is 0. You all might be knowing it. So 0 I cap minus 4 j cap. So -1 divided by 1 is -1. So minus k cap. Okay, so this is the answer of del psi. Now substitute in the unit vector n, since we need to find this n cap here. So n cap is equal to del psi, that is minus 4 j cap minus k cap divided by magnitude of this part, that is minus 4 the whole square plus -1 the whole square, that is n cap is equal to minus 4 j cap minus k cap divided by 4 square minus 4 the whole square is plus 16 plus 1, that is square root of 17. So this is the answer of n cap. Now finally the directional derivative del phi dot n cap, that is equal to del phi, we have got it as 4i cap plus 3j cap plus 6k cap dot product with minus 4j cap minus k cap divided by root 17. Okay, so here again take 1 by root 17 common outside and then do the dot product. So I term is not there, so 3j cap and 4j cap, do it separately. So 3 4s are 12 along with minus sign, and j cap is 1, and 6k cap and this k cap term, so 6 into -1 is -6. Okay, so our answer is -12 minus 6, that is -18 divided by root 17. Okay, so this is our answer for directional derivative. So hope it is clear. So look at this problem once again and try to solve it. Very easy one. Yeah, let us get to the next problem now. This is one more important kind of problem where directional derivative part is done. Now we are going to solve related to the finding the angles between the surfaces. Okay, find the angle between the surfaces x square plus y square plus z square and x square plus y square minus z square at the given point, that is 2 comma minus 1 comma 2. Okay, so here we are having two surfaces, so separate two gradients we should be finding, that is del phi 1 as well as del phi 2. Okay, yeah, so let us find that first. So here first write the two surfaces phi 1. So phi 1 is equal to x square plus y square plus z square, and phi 2 is equal to x square plus y square minus z square. Okay, now we should be finding del phi 1 first, gradient of phi 1. So according to the formula, first partially deriving with respect to x here. Okay, that is here we have only this term as x, so we should be writing it as x squared. Its derivation is 2x into I cap. So similarly y square and z square we are having, so simply we can write 2y into j cap plus 2z into k cap. Okay, now substitute the value of x, y, z. So value of x is 2 into 2 I cap plus 2 into -1 j cap plus 2 into 2 k cap. Okay, so final answer of del phi 1 is equal to 2 2s are 4, 2 1s are 2, so minus 2 j cap plus 4 k cap. Okay, so this is the answer of del phi 1. Similarly for del phi 2 also the same thing again. For this term, do the partial differentiation. We have x square, y square, z square along with one negative sign. So what I am doing is, again I am writing the same thing, 2x I cap plus 2y j cap. So here now instead of plus write minus 2z k cap. Okay. Now substitute the value of x, y, z. So 2 into 2 I cap plus 2 into minus 1 j cap minus 2 into 2 k cap. Okay, so our answer of del phi 2 is equal to 4 I cap minus 2 j cap minus 4k cap. Okay, so this is the answer of del phi 2. Now to find the angle between the surfaces, the formula is given as cos theta is equal to del phi 1 dot del phi 2 divided by magnitude of del phi 1 into magnitude of del phi 2. Okay, as you know, now we are going to substitute those things here. So cos theta is equal to del phi 1 is 4 I cap minus 2 j cap plus 4 k cap dot product with del phi 2, that is 4 I cap minus 2 j cap minus 4 k cap, the whole divided by the magnitudes, that is first magnitude of del phi 1, that is 4 square plus minus 2 square plus 4 square into magnitude of del phi 2, that is 4 square plus minus 2 square plus minus 4 square. Okay, so cos theta is equal to, now do the dot product, 4 I cap into 4 I cap. If you multiply 4 I cap with these two terms, it is invalid. It would be equal to 0 because the opposite unit vectors is equal to 0. So multiply I cap term with I cap, j cap term with j cap, and k cap term with k cap. That is 4 into 4 is 16. Then minus 2, I cap is 1. So no need to write that. Minus 2 into minus 2 is plus 4. 4 into minus 4 is minus 60 divided by, so here if you simplify here what we are getting, 4 square is 16, 4 square is 16 and minus 2 whole square is 4. So 16 plus 16, 32 plus 4 is 36. Here also the same thing, since the signs are changed but we do the whole square term, so it would be as it is positive only. So here also we would be getting root 36. So 16 gets cancelled, 4 divided by root 36 is 6 into 6. Okay, that is cos theta is equal to 4 by 36. So if we solve it, we would be getting 1 by 9. 4 ones are 4 nines are. So what our answer is, final theta we needed, right? So theta is, bring cos to other side, it would be cos inverse of 1 by 9. Okay, so this is the answer of theta, cos inverse of 1 by 9. If you want to further solve it, put it in the calculator. Okay, keep this in the degree mode and type cos inverse of 1 by 9 and whatever angle we get, mention it. Okay, if you want, I am showing it here. Okay, in the calculator, keep it in the degree mode, cos inverse. So press shift and this cos inverse of 1 divided by 9 and you would be getting something around 83.62 degree. Okay, you can write that also. And because this vector algebra is not about angles and all, okay, you should not be writing accurate angles, so no need to mention any angles. So simply you can write this much and conclude the answer. Okay, yeah. So this was about this angle problem. So hope it is clear. So let us solve one more problem and wind this session. Okay. So this is the next problem, the fifth problem of this topic. Find the angle between normal to the surface xy minus z square at two different instant of points. Okay, so in the previous problem they had given two surfaces. Here they had given only one surface, but they had given the values of xyz as different. Okay, so if we have the different values of xyz, then obviously we can conclude by saying that the surfaces would be different, because we would be getting phi1 and phi2 different values after substituting the values of xyz, right? So here again they are given two surfaces. We should be considering this surface only as two surfaces and solving this problem. Okay, let us solve it and let us see what we would be getting the answer as. First, del phi 1 okay, that is xy minus z square. So first partially differentiate with respect to x. So here we have x is 1, differentiation is 1, so here y into I cap, plus next with respect to y, so here we have y term, here we don't have, so this would be 0. A differentiation of y is 1, so we would be left with x into j cap, plus z term we have here only, so this would be 0, so minus 2z into, so differentiation of z square is 2z, we have minus sign, so minus 2z into k cap. Okay, so del phi 1, after substituting the value of y, x and z, we would be getting it as y is 1, x is 1 and z is 1, so I cap plus j cap minus 2 k cap. Okay, so this is the answer of del phi 1. Similarly for del phi 2, again the same thing, it won't be getting changed because we have given only one single surface, right, minus 2z k cap, but here the values of x, y, z changes. Okay, so y is 2, x is 2 and z is 2, so 2I cap plus 2j cap minus 4k cap. Okay, so like this we got the values of del phi 1 as well as del phi 2. Now substitute that in the formula. Cos theta is equal to del phi 1 dot del phi 2 divided by magnitude of del phi 1 into magnitude of del phi 2, right? So cos theta is equal to del phi 1, we have got it as I cap plus j cap minus 2k cap dot product with 2I cap plus 2j cap minus 4k cap, the whole divided by del phi 1. Del phi 1, that is magnitude of square root, that is the coefficients 1 square plus 1 square plus minus 2 the whole square into again the square root of 2 square plus 2 square plus minus 4 the whole square. Okay, so cos theta is equal to again I cap into 2I cap, so 1 2s are 2 plus j cap into 2j cap, so again 1 2s are 2 plus minus 2k cap minus 4k cap, minus minus is plus, 2 4s are 8. Okay, the whole divided by, so here what we are getting, 1 square plus 1 square, that is 1 plus 1 is 2 and minus 2 the whole square is plus 4, so 4 plus 1 that is 6, and here what we are getting, 2 square is 4, 2 square is 4, so 4 plus 4 is 8 and minus 4 the whole square is 16. Okay, 16 plus 8 is 24. Okay, yeah, so this we can write it as 8 plus 2, 10 plus 2, 12 divided by, this we can split and write it as root 6, and this we can write it as we can write this as 2 into 4 into 3. Okay, or simply we can write it as root 6 into 4. Okay, so if we write this, what we are getting, 12 divided by root 6 and root 6 into root 6, so here root 4 is equal to 2, so the value of root 4 is 2, right, and root 6 into root 6 is root 36, so 12 divided by root 36 is, again we know that it is 6 into 2, so 12 by 12, so 12 by 12 is 1, right? So cos theta we would be getting it as 1, that is theta is equal to, bring cos to other side, cos inverse of 1, so theta would be equal to, if you substitute that, cos, shift and this term, cos inverse of 1, it is 0. Okay, so our value is theta, the angle between the normals to the surface for this question is equal to 0. Okay, so yeah, hope this is clear how to solve this problem. So that's all for this video, guys. We have solved problems related, one problem related to directional derivative and two problems related to the angles between the surfaces. Okay, hope it is clear. Yeah, so let us see you in the next video with some more concepts related to this module of first chapter, vector differentiation. Again, second chapter is yet to be started, that is the vector integration. That is a bit more complicated, that we are going to see in the further sessions. Okay, yeah. So thank you for watching till here, those are watching. So if you are watching and if you like this content, you can press the like button, subscribe to our channel for the latest notifications, and stay tuned for the upcoming videos, and share these kind of videos to your friends, neighbors, relatives, whosoever is related to you. Okay, yeah. So this playlist would be continuing like this only. All 5 modules you would be getting, access it and try to learn something. Okay, that's all from my side, guys. Thank you.